Thank you everyone for joining the Moldex 3D webinar series. This is the first webinar of the year, so I welcome you all to the new year, and with the new year comes a lot of new topics for the Moldex 3D webinar series here. The first one that we're going to be doing is this resolving pressure discrepancy issues in simulation. And this is actually a topic that has been very widely contested and very widely researched throughout different facets of the injection molding industry, as well as other types of industries out there, and different types of molding and all different types of parts. This is a very common topic for simulation guys to be discussing. All right, so the topics that we're going to be going over, first of all, what is sprue pressure? So maybe if anybody doesn't know what sprue pressure is, we're going to go over that for a little bit. Where can the sprue pressure discrepancies originate from? So what are the different causes? Where can we see these pressure discrepancies? How can we fix them? And some final remarks. All right, so let's jump right into it. What is sprue pressure? So sprue pressure is the reading from the melt entrance or from the pressure sensor, which is typically located around the nozzle. In other scenarios, you can actually get a reading directly from the screw itself. Moldex 3D uses solid mesh for all facets of the simulation, so anything that's modeled in Moldex 3D will be tied to this pressure drop as long as it's dealing with the melt system, that being the runner and the parts. So everything that's modeled in, there's going to be no approximations, there's going to be no adjustments, no assumptions or anything like that. The solid mesh is used directly to calculate the pressure drop through the system, that being, again, the runner and the part traditionally. All right, so everything after the melt entrance will begin to cause flow restrictions. So as the melt progresses through the melt system, the amount of pressure required to push that material forward increases, and that's where this sprue pressure comes from, or that's where this pressure curve that we're going to be talking about is going to come from. The restriction of flow will gradually increase the pressure requirement, like I mentioned. All significant regions of pressure loss should always be considered in the simulation. So this is actually a thematic statement that I'm going to be reiterating quite a few times throughout this webinar. Whenever we are looking at pressure differences, it's always important to make sure that everything is modeled into the software. The software can only calculate things that are included.